name's Jonathan, and I'm one of the presidents of our undergraduate physics club. We're going to be putting on our little demo show for you, so stay tuned. But real quick before we get started, I just wanted to remind everyone not to try anything you see here today at home. A lot of these demonstrations are very dangerous. We've taken lots of safety precautions to make sure you're safe and we're safe, so don't try any of this at home because you could get injured. But without further ado, I give you the Undergraduate Physics Club performing CSI Swing.
Okay, we got the overwhelmingly large telescope. Now we just have to get out of here fast.
I think I see an emergency exit. Look at this sign. It says break in case of emergency. I think there's a key inside the ball. We just need to break it and we can get out. It's bouncy. I don't know how we're going to break it.
Well, here's some liquid nitrogen. Maybe we could use that to cool it off enough to break it.
And I'm going to cool down my banana a little bit.
So, most of the air you see around you is made of nitrogen. And when you cool it below about negative 300 degrees Fahrenheit, it condenses into a liquid like you see here. And now the molecules in the rubber ball are long strands, like long chains, like spaghetti. And so when they get tangled up, and they're warm, they can expand and contract, and that allows the ball to bounce. But when they're cold, they're rigid, and they can't expand and contract without breaking. So hopefully, if we can cool the ball down to negative 300 degrees Fahrenheit, we can use this. We can smash it and get the key out and escape.
All right, I hope it's almost ready. Can you get around in there? It's okay, let's see if we can break it.
Hurry!
We need to get out of here. Pull it down some more. All right.
Yeah, he wants to be stealthy.
Oh, my banana is okay, let's try it again.
Okay. All right, we gotta get out of here.
Wait, first let me eat my banana. Ouch! We're walking around with that banana. We need to get out of here.
Let's smash the circuit breaker. Oh no! Someone broke in and stole the overwhelmingly large telescope.
We need to find out who did this and get that telescope back. We don't have any chance of observing it from the west.
This sounds like a job for the cool science investigators.
Now, the first thing we need to do is get the power back on. Someone grab the Tesla coil and let's fire it up.
I hope this gets lights back on.
No. It should have.
Where?
There we go.
The Tesla coil is a circuit designed by Tesla. It uses two coils to create an electric current. The high voltage that you can see in these electric arcs. And you can use this to power a light without the use of wires. So we're able to turn lights back on without using any wires. What's this weird residue on the floor?
Yeah. Oh, it's over here too. You know, I bet the thieves brought it in.
We must have. Maybe if we burn it, we can tell what it is and find out where the thieves are hiding out.
I have just the thing. This here. So what I'm getting out now are a bunch of salts of various compositions. And as my colleague Talia said, we are going to burn each of them and then figure out which one of the powders this one is. And that should tell us a little bit about where the thieves come from. Of course, I'm going to use goggles for this. And gloves, which are oddly cold. Okay. So. Alright, so the first salt I'm going to burn is calcium chloride. And as you can see, it burns with this bright orange color. The next one is a blue salt called copper sulfate, and its flame is green. Common table salt, or sodium chloride, burns a sort of yellowish color. Lithium chloride burns a bright red. And finally, copper oxide burns sort of a lighter orange color, lighter than the calcium chloride. Now, let's see what color this powder burns here. The bright red flame means that it's lithium chloride. Now, the reason this works is because the heat of the flame excites the electrons in the salt, and they absorb a very specific amount of energy. When they return to their original state, they emit that energy in the form of a very specific color of light. That's what makes the flame change color, and that's how we know that this particular powder is lithium chloride. Now, lithium chloride probably comes from some of the caves around Bloomington. That must be where the thieves are hiding.
You're right. We should go and check out these caves. Come on.
Lab tech, come set up the course field.
There's so many caves.
I know, but wait, I hear someone talking. I think this is the right place. Yeah.
Oh, I see our colleagues over there.
No.
They must have been working late last night with the telescope.
Well, we can't just stand there. Let's go save them.
Oh, wait.
Record traps.
If they were smart enough to get through our security system, I bet they have one of their own.
That sounds right. Check.
I bet these thieves are the type to have lasers flying around. We should use this dry ice that we brought with us to see if there are any lasers.
Always have to drive.
Now, dry ice is solid carbon dioxide. Carbon dioxide is often, well, it is found in the air that you breathe every day. But when you get it down to negative 109 degrees Fahrenheit, it turns into a solid that you can see here. Now, when I'm going to put this solid carbon dioxide into this cup of water. And when I do this, this water is so warm compared to this dry ice that it's going to cause this dry ice to go directly from a solid to a gas. And this gas will allow us to see the laser.
Oh, wow.
Here's the laser.
There is a laser indeed.
Wow, there it is. It's a good thing we didn't run through it.
Yeah, sorry about that. Totally. All right. Guess we have to go through it now.
Okay. Yeah, I think our best option is to crawl.
I agree.
Wait.
You're dead. You're dead too.
Oh no, the scientists!
Well. It looks like a group of scientists has come to reclaim their overwhelmingly large telescope. No matter, they'll never make it past our state-of-the-art security system. Ready the potato can.
Alright, so in either end of this PVC pipe, I put a chunk of potato. I just ran it through the potato. And so what this did was it trapped the gas inside. So there's a finite volume of gas with a finite number of molecules under a certain pressure. If I use this stick to move the potato pieces closer together, then it will increase the pressure inside the tube, causing one of the potatoes to shoot out the other side. I can't fire again. I only got one potato. They're out of season.
Well, I guess we'll have to resort to something a little more drastic. Bring one of the hostages and we'll put him on this bed of nails.
Nice knowing you, Mom.
That's very nice of you.
Safety first.
Or last.
Oh, I know he's good.
You're ready to die.
Leave now or we'll break this cinder block on your colleague's chest.
No, we can't. We have to get the telescope. Yes. Okay, come to the team.
Go ahead.
Take
Come on.
Still in one piece.
Why didn't that work?
So it worked on the banana because there were just a few nails, and there's quite a bit of force just on those few nails dropping the banana. But since I had a bunch of nails on my back, there was actually a pretty low pressure on each nail, so my skin didn't get punctured. I think this controls the electronics of your full steel.
You should. I have just the device. Our handy hand crusher that we also brought with us to the game.
I don't know how they plan to crush our force field generator with that. Just electricity.
Our hand crusher here has several capacitors inside of it. Capacitors store large amounts of electrical energy. Now, we are currently charging up the capacitors, and when we have enough energy, we are going to release the energy into a coil that we have around the can. Now, this is going to create a current in the coil, which will induce a current in the can. This current will cause a magnetic field that will force the can to be crushed without us even touching it. Now, sometimes this can be loud, so our assistant here will count to 3 when he is about to crush the can, and if you want to, you may want to cover your ears if you don't like loud noises. Okay. It takes some time for the capacitors to be charged fully enough to crush the can. So that's what we're waiting on now.
It's okay. We don't think it's going to work anyway.
Yeah.
You take as long as you need.
Yeah.
We will.
Keep
and
stalling.
Yeah.
Maybe we will.
We still have their telescope. So.
Yeah,
We're still attacked.
It's ready. You got
I think it's ready. Okay.
1, 2, 3.
Wow, we crushed it.
That was just a decoy. You'll never find our real force field.
Yeah, you'll never guess where we really put it. In the oil drum. Oh, I don't think I was supposed to say that.
How can you reveal our secrets? It's okay. We still have another hostage. This one's in for a real treat. Prepare the bowling ball.
Oh.
When it comes back, it's gonna smash it.
Oh my God.
What's wrong? You said all these evil torture devices work.
I don't know. Let me check my calculations.
You stay put.
Oh, I forgot to carry the two.
You forgot a bit more than just carrying the two.
What the thieves failed to consider was a little thing called conservation of energy. The ball was right in front of my face and it had a particular amount of potential energy. As it swung through its arc, that potential energy was converted into kinetic energy and then back to gravitational as it was over here. The same thing happened on the reverse, but according to conservation of energy, the ball couldn't have any more energy at the top of its swing than it did when it began, and so the ball stopped about here, which saved my pretty face.
It looks like you're all out of hostages, so it's time to give us our telescope back.
Fools, we still have our force field. You're never getting that telescope.
We'll just have to find a way to break through your force field and pull up guys.
How are they going to get
what are they
rid of
gonna
our server?
What's science going to do to break an oil?
Physics! Eureka! I think we have a way to destroy that force field generator.
The generator that your force field uses uses a lot of energy. So, this is a lot of heat. Use that to our advantage. Ready the hose.
And
What
we'll
are they going to do with the hose? What? They're going to get our force field generator wet? Oh
You get a little break.
no. Oh no.
It's waterproof, guys.
Yeah.
It's a metal oil.
It's just
Been
wow.
heating for quite some time. You're probably full of steam coming out at quite a rate. So what you're going to do is cool the barrel down. So it was filled with steam, but the steam is now going to condense. And a vacuum is forming inside here. And atmospheric pressure will eventually crush the drum, destroying their electrons.
Yeah, okay.
What else?
Keep going, guys.
Yeah. Oiled again by science. Great, science wins.
Cool science investigators saved the day once again.
All right, everyone, thanks for coming. That's our show, but we have free frisbees that we're going to throw out, so grab one. They're freezing it.
With the water balloon now?
It's liquid oxygen, so you bring it back out. And then it'll
Liquid oxygen.
Oh, really?
This air is mostly oxygen and that turns into liquid. It's like 20%
I'm interested to know what the inside of the homes of your parents' houses look like when you were little children.
You can ask them, they're right there.
I'm thinking disaster zone. Disaster zone?